how this thing is made internally. Command or control click string.java. It's actually a class string. The final keyword implements and everything we'll cover in object-oriented programming, but you know it's a class of Java. Okay, cool. So that's the first point. And now the second point that we have to understand about string is that every string that you create, it's actually an object of type string. We also covered this with the example I gave with arrays and stuff. Similarly, there's an object. So this is an object. This is a reference variable. This is what? Data type. Okay. And this thing is actually a string object. Very simple stuff. Now the next point is that how is it actually being stored internally? Okay, so let me tell you something. So if I write something like, let's say if I write something like string A is equal to Kunal, then I say string B is equal to Kunal. So my question to you is, you might be saying, hey Kunal, is this creating two different objects or is it pointing to same object? So for example, is it doing something like this? A is in stack, B is also in stack, this is heap. A is in stack, B is in stack, this is heap. Kunal is created here, pointing to this. Or Kunal here, Kunal here. This particular point that I have given, string A is equal to Kunal, string B is equal to Kunal. You might be asking, hey, how is it being stored in the memory? Is it option A or is it option B? Which one is it? Is it creating two different Kunal objects, or are both the reference variables pointing to the same object? What is happening over here? Think about it. Let me know. I mean, how can you let me know? Um, make sure you like, share, and comment. That's it. All right. So let's see how it is working internally. So there are two concepts to be understood over here. Okay, two concepts regarding how this is working. Concepts. Concept number one we need to understand is of string pool. Question number two is immutability. Let's see what is string pool. Actually, it is being stored internally like this. When you write something like string name is equal to Kunal, when you write something like this, it is actually being stored in the memory like this. The string pool. Kunal comes over here. Name is pointing to Kunal. Okay. Now you may be asking, Kunal, what is this string pool? String pool is nothing, it's just a separate memory structure inside the heap. Okay, what is string pool? String pool is a separate memory structure inside the heap. And now you may be asking, okay, Kunal, that is very simple, no problem. What is the use case? Why a separate pool? Why can't you just put it out in the heap normally, like you do for every other object? It's a good question. So the answer for that is, all the similar values of strings are not like recreated in the pool. So if I write something like string B is equal to Kunal, it's going to be like, hey, Kunal already exists in the pool. No need to create it again. Point B to this Kunal. Similarly, over here what is actually happening is something this is happening. A, B, heap, pool, Kunal, like this. So what is heap? Very simple stuff, just a separate memory. What is the use case? Makes our program more optimized. Okay, in this way I don't have to create, if I'm saying 10 reference variables are equal to Kunal, it will not create 10 objects of Kunal. Okay, cool. Another doubt you can get. One more doubt you can get over here. What doubt can you get? What doubt you may be getting right now? Hey Kunal, you are doing something similar with arrays. In arrays also, let's say two or more objects are pointing, two or more reference variables are pointing to the same array. That's fine. You are also doing something similar over here. But Kunal, what if the change in this object is made via this reference variable? It will also be changed for this. This is a very dangerous stuff. You all realize this, right? When we did it before. Two reference variables pointing to the same array. Change from one reference variable in that array will also lead to change for second reference variable because both are pointing to the same array. The baby example that we give, that was very brilliant example. I don't think you should be having any doubt there. Same doubt you can have over here. Kunal, what if you try to change the value of this object via name? Would it be changed for B or not? Like it was changing for arrays? The answer is no, it will not change. Now you will get confused. Kunal, why? You are the one who told us that if you change the original object via any one of the reference variables, the object is being changed for all of these. You are the ones who you are the one who told us. And why are you, saying that it will not change for this and this? So basically what I'm saying is if you try to change this object via this reference variable, it will not change for B. What might be the reason here? Immutability. So the answer to your doubt is what? You cannot change. You cannot change. You can't change this object. You can't do it. Problem solved? Doubt solved? You can't change it. You cannot change this object because strings are immutable in Java. You cannot change the object. You cannot modify this object. Object made, done. If you wanna rename this to, let's say, Kunal, you can't change. You can't change this object. You can't do it. Problem solved? Doubt solved? You can't change it. You cannot change this object because strings are immutable in Java. You cannot change the object. You cannot modify this object. Object made, done. If you wanna rename this to, let's say, Kunal Kushwaha, create a new object. I'll show you in detail right now.
Moriti.
For example, change it. You cannot change this object because strings are immutable in Java. You cannot change the object. You cannot modify this object. Object made, done. If you wanna rename this to, let's say, Kunal Kushwaha, create a new object. I'll show you in detail right now. So for example, what I'm trying to say is that you cannot change. What I mean by that is this. So here I'm saying string name is equal to Kunal, and here and then I'm saying, let's say, string, or I can just say in simple terms, string A is equal to Kunal. Then I can say string B is also equal to Kunal. I will also explain your doubt. You might be asking like, hey Kunal, why is it that strings are immutable? The short answer is security, for security reasons. So we know that for optimization point of view, they have string pool where many are, many objects, many reference variables can point to the same. In this example, A and B are actually pointing to one object only. Okay. How to check that? I'll also show you that. Don't worry. So one thing before that I want to show is how do we change the object. So if I'm saying something like, I don't need two objects right now. I just need one. So I'm saying something like print A. It's going to give me Kunal. Then I say something like A is equal to something like Kushwaha. Then I say print A. This will print Kushwaha. Let's try to see. Let's try to see what is happening. It prints Kunal, then A is equal to Kushwaha, then it prints Kushwaha. Now you might be having another doubt. Kunal, you said objects cannot change. String objects cannot change. You just said it. Then how are you changing the value of A to Kushwaha now? You are the one who said that string objects cannot change. Take a look at it very carefully. I am not changing this object. I am creating a new object. Why am I saying this? Because people say these things again and again in comment section. So I did not change this object. I created a new object. How? Let's see. Let's bring back our iPad. So what is happening over here? When I said string A is equal to Kunal, I did something like this. So I said string A pool Kunal. Then I said A is equal to Kushwaha. This actually said okay, create another object Kushwaha and point this over here. As simple as that. Did I change this object? No, I just created a new one. Now another question you may have is what is going to happen with this object now? A pool Kunal. Then I said A is equal to Kushwaha. This actually said okay, create another object Kushwaha and point this over here. As simple as that. Did I change this object? No, I just created a new one. Now another question you may have is what is going to happen with this object now? What is going to happen with it? You tell me. Garbage collection? Okay, cool. This actually said okay, create another object Kushwaha and point this over here. As simple as that. Did I change this object? No, I just created a new one. Now another question you may have is what is going to happen with this object now? What is going to happen with it? You tell me. Garbage collection? Okay, cool. So this was the two important points, string pool and immutability. So why is it immutable? We all know now, because for security reasons. If you are storing someone's password, okay, or someone's name or something, okay, let's say more and more people are named Kunal. So obviously it's going to have the same object, but different person will have name Kunal. Let's say someone decides to change their name. Okay, imagine this scenario. Why immutability is a good example. Why we can't modify string objects. So let's say person 1, person 2, person 3, person 4, all are named Kunal. So hence all of them will be having just one object Kunal over here, right? In the heap memory. Now suppose one person decides to change their name. If it was not immutable, if person 1 decided to change their name to Karan, okay, so this will change its name to Karan. If this was if it was allowed for us to modify this, like arrays are allowed for us to modify, hence this person 1 tried to change their name, all of the other people's name will also be Karan then in the database. For security reason, strings are immutable. There was a simple explanation. Okay, now another proof I want to show you about this is how can we actually check, Kunal? Kunal, how can we check whether this is happening? happening or this is happening, whether this is happening or this is happening. How can we check? How do we compare values? How do we check whether more than one reference variable are pointing to the same object or different object? Let's see. Let's see how we can do that. So how can we do this? I'm going to create another class. I'm going to say comparison. You can see I am also following comparison, like sorry, the convention. So whenever I create a new class, it's also in capital letter. Don't worry, we'll go into the class and methods and everything that it provides. Internally how it's working, don't worry right now. Okay, because we will cover that in OOPS, object-oriented programming. So I can say string A is equal to Kunal. Then I can say string B is equal to Kunal. You know by now that this is what? This is in pool. This is in string pool because the value is same. But what is the proof for this? Equal to equal to. If I say print A is equal to B, what is it going to show? True. So what is the reason for equal to equal to? What is this thing doing and why is it IntelliJ IDEA giving me a warning? Let me tell you how. So this is very important point. Comparison of strings. Pay attention. There are two ways you can compare. Okay, comparison of strings. Okay. Equal to method. Okay, this is actually a comparator. Okay, comparator. All right. So in this case, what happens is that if A is pointing to Kunal, B is pointing to another Kunal. Let's say these are two different objects. I'll also show you how to create different objects. In this case, equal to will give false. Sorry, A equal to B. A equal to B will give true. So what is equal to doing? It actually checks for both the values and the reference variable if the reference variable is pointing to the same object. So checks if reference variables are pointing to same object. And in our example that we just ran, A is equal to B was giving us true. That means that what does it mean? It means this case is happening. Okay, very simple stuff. All right, cool. Let me tell you one more thing. Let me write it down over here somewhere. I will create okay, so this was very simple. Now let me show you in which case this will be. How can we actually have this thing? Kunal, you told us that string A is equal to Kunal, string B is equal to Kunal. It will point to the same object. In what scenario will this be two objects? how to create different objects of same value. So you can cheat a little bit and explicitly tell Java, hey Java, I don't care what optimization you are doing. I am telling you explicitly create a new object. I don't care if it is already in string pool or whatever. I don't care. Okay, create a new object like you do usually. And what do we use to create objects? Recap in arrays. What were we using to create new objects? New keyword, int arr is equal to new int array size. New keyword. So if you say something like string a is equal to new string Kunal, string b is equal to new string Kunal, it's actually creating these values outside the pool but in heap, because it's object, so it will be in heap only. So internally it's working something like this: a b heap pool, but Kunal will now be over here outside of string pool. Now if you do a is equal to b, it will give me false. Even though the values are same, the value is same, but it's not pointing, these two a and b are not pointing to the same object. In that case it will give false. So when you only need to check value, when you only need to check value, use dot equals method. Okay, let's see all of these things in action. So if I say something like this, it will give me true. But if I say something like, string a is equal to new string Kunal, name1, string name2. Now if I print name1 equal to name2, even though the value is same, it may be pointing to the different object because I have explicitly mentioned. Run. False. I will give false. False. Make sense? Alright. But this is not how we want to create strings. We want to utilize the string pool. Hence we will do it in this way. Okay. Similarly, if you're doing something like this, if you're doing something like, string c is equal to a, this is also pointing to the same one. I can just say print c is equal to a. It will give me true. True. And what if I only want to check the values? I can say print name1 dot equals name2. So this is a comparator and this is a method or a function, you can say, but it's a method. Okay, method, like functions that are in classes are known as method. We'll cover this in detail right now, don't worry. The string methods and everything we'll cover in detail. Let's run this. Now it will give true because it does not care whether the reference variable are pointing to same object or not. It just cares about the value. Let's run this. It should give me true. I'm getting true. If I change the value, if I add some spaces over here, now these two strings are different. False. If I write it as something else, I can say something like, like this. Obviously false for obvious reasons. Equal to will also give false because since these are two different objects, it's like something. Now about methods and everything we'll cover in detail. Let's run this. Now it will give true because it does not care whether the reference variable are pointing to same object or not. It just cares about the value. Let's run this. It should give me true. I'm getting true. If I change the value, if I add some spaces over here, now these two strings are different. False. If I write it as something else, I can say something like, like this. Obviously false for obvious reasons. Equal to will also give false because since these are two different objects, it's like two different values means two different objects. So false, false. Very simple. Nothing new over here. All right. Cool. Okay, so if I try to look at how this is built like internally, we know this is a class. Class we already discussed in brief when we were doing like arrays and stuff. Obviously, we will go into the details, but right now for in brief, we know it's a name group of properties and functions. Properties like something like, this is a properties, properties, properties. Functions like something like this. We have a string. The constructor is over here. We'll cover what is constructor, what is this keyword. Everything will be covered in OOPS. Okay, don't worry. Internally, right now, you can see that internally Java, it's also like a byte array or something. Okay, so the value is used for character storage. So internally, it's basically you can say acting like a character array. It is not like mimicking the character array or anything because we cannot do something like this. I can't do something like let's say name one, right? So I can't do something like name one of 0. Can't do something like this because in arrays we can do this. Here we cannot do it. Even though it's sort of like you can imagine collection of characters, but we can't do it like this. We have to use a method called get or not get index. Sorry, char@, yeah, char@ index number. So now I can put index number 0. So it's going to print which is the character at index number 0, k. So it's going to print k. K. Internally how it's working, let's see. So it's calling some other function called char@, it's calling some other function called char@, and so on and so forth, doing some bitwise operations with hexa or whatever it's doing. Internally it's like a array only, and it's the index. It's taking the index of that array directly internally. So internally it's working like array only. For us, it's just like a object type. Okay, we can imagine it's like a string object type for imagination purpose. Don't dive deep into like complications of all these things. Okay, we'll cover more about these methods and how this thing is working right now. Now, a few of the basic things that we have already covered but haven't dived deep into it. So I don't think we need to, because in the initial example when we were looking at command line arguments, right, when we were doing the video of first Java program, there we learned about the command line arguments. So when you write Java, Java C, and then you compile it, then you write Java and file name, and then you write the command line arguments, it will actually be stored in this variable, a string of arguments, whatever you type in your terminal when you write the Java command. If you don't understand what I'm saying, this thing, command line arguments, if you don't understand these three words, look at the previous videos of the Java Bootcamp. The link is in the description for the entire playlist. Check out the first Java program video. In that, we have timestamps as well, so you will understand and find it very easily. Please check it out once. Okay, so command line arguments, as you can see, it's also using string. Let me show you something else that is also very interesting that we've already done before. Let me show you one more thing, how, if we pass in various objects, how these things are actually being printed. We did arrays.toString. Remember when we were printing arrays and I told you I will teach this to you later on. Let's see. I'm going to name it as output. Okay. We'll also do some pretty printing over here. Let me show you. Okay. So when I do something like int a, or not, directly I can print. I can say print 56. If I print this, it's just going to print 56. Okay, nothing new over here. So here you can see that println, we will cover more about, this particular reference variable has a method called, this is a reference variable uh, of type print stream, and null basically means the standard output stream, which is like your um, console over here. You can also change it to something like file or whatever. Don't worry much about this. I told you in the first lecture, don't worry about this line, because we will cover this in detail in object-oriented programming. What is system, what is out, or whatever. For now, let's just imagine out is a class that lets us print stuff, and it's in sorry, out is not a class. Out is a variable of type print stream. So print stream is a class. Out is a variable of type print stream, and it has a method or a function is a class that lecture to a standard output stream, which is like your um, console over here. You can also change it to something like file or whatever. Don't worry much about this. I told you in the first lecture, don't worry about this line, because we will cover this in detail in object-oriented programming. What is system, what is out, or whatever. For now, let's just imagine out is a class that lets us print stuff, and it's in sorry, out is not a class. Out is a variable of type print stream. So print stream is a class. Out is a variable of type print stream, and it has a method or a function in it. The print stream has a method in it called println. Print stream class has a method in it called println that we can use. So in simple terms, Java people have made these methods and everything, so we can print it very easily. Okay, internally how it's working is, let's say I do println number, I can say println string, I can say println, sorry, string will be double quotes. I can take another data type, something like an array. So new integer array 2, 3, 4, 5, something like that. All of these println will be different. Let's say this is taking integer, that is true, it's taking an integer. This is taking a string, that's true, this one is taking a string. This one is taking an object type, that's true, it's taking an object type. We already covered this in functions. This is known as what? Function overriding. Okay, we already covered this. All of these have the same name, but the arguments are different. Function overriding. If you, sorry, not overriding, overload that string will be something, print it very easy. Return class. Out is a variable of type print stream, and it has a method or a function in it. The print stream has a method in it called println. Print stream class has a method in it called println that we can use. So in simple terms, Java people have made these methods and everything, so we can print it very easily. Okay, internally how it's working is, let's say I do println number, I can say println string, I can say println, sorry, string will be double quotes. I can take another data type, something like an array. So new integer array 2, 3, 4, 5, something like that. All of these println will be different. Let's say this is taking integer, that is true, it's taking an integer. This is taking a string, that's true, this one is taking a string. This one is taking an object type, that's true, it's taking an object type. We already covered this in functions. This is known as what? All of these println will be different. Let's say this is taking integer, that is true, it's taking an integer. This is taking a string, that's true, this one is taking a string. This one is taking an object type, that's true, it's taking an object type. We already covered this in functions. This is known as what? Function overriding. Okay, we already covered this. All of these have the same name, but the arguments are different. Function overriding. If you, sorry, not overriding, overloading. Function overloading. Function overriding is something different. We will cover in object-oriented programming. It's based on inheritance and stuff. This is function overloading. We covered this in detail. If you might be having any doubt, hey Kunal, what is function overloading? Pause this video, watch the functions video. Over there also timestamps are given. Links in the description. Okay, in detail we have explained this already. So this is function overloading. Now notice something what is happening. For string, it's directly just printing the string. Okay, it's saying string dot value of. Value of is basically just getting the value of it. Okay, what is the meaning of this thing? See, if object is equal to null, print null. Otherwise, print the toString method of that. Just get the string and whatever. A lot of things are going on over here that you may be having a doubt on. Let me break it down for you. Let me break it down for you. First thing I want to share with you is, if I say string name, that's it. I don't initialize it, I just declare it. Then I print it. What is it going to show? Right now it's giving me like some, some error, like it might not have been initialized. So maybe if I do something like, null, null, or something like this. If I print it, it's giving me null. Okay, let's see how many outputs we are getting. Try to see that. Okay, so basically right now what we are doing is we are trying to see how Java, the println function method, is printing values of different types. Let's look at it one by one. Don't worry, all the files that I have opened right now I will explain in detail starting right now. So let's first look at an integer. Let me just close this thing. Let's first look at an integer, how the integer is getting printed. So when I do print 56, it's definitely going to print 56. How is it working internally? How is it printing 56? So basically it's calling the toString method. Okay, value of calls the toString method. ToString method. Anything you print in println, it calls the toString method for everything. Okay, println, it's saying string dot value of, okay, value of. So it's println is calling value of, which is calling toString. Means, okay, you have it as an integer, give me the string value, then I will print it. You have it as a string, give me the string value, I will print it. You have this as an array or an object type, give me the string value, I will print it. So it's saying value of this, then it's saying integer dot toString I. It's converting into a toString, and then you can say it's doing something over here and printing it. Okay, that's why in the end it's just printing 56. So in the end it's just saying get the value of this thing, and the value is just saying print integer dot toString. Okay, internally it's doing whatever it does and just returning the string or whatever. Don't go into details of this. Okay, internally as you can see it's only a string. In the end it's just returning a string only. Okay, cool. The next thing is, if you want to print a string only, so whatever you put in println does not matter which data type, in the end it's going to print string over here only. Okay, if I print of type string, it's going to definitely print string only. Kunal, it will say Kunal. How it's working internally, it's taking a string, yeah, that is correct. Value of, correct, same thing. If it is null, print null, otherwise toString. Again toString comes over here. What is this thing? I'll show you later on. Okay, so string dot toString is just saying, okay, what is the string value of this Kunal? It's Kunal only. Don't dive deep into how that toString is working, but not that important. Okay, cool. It's very simple when we do object-oriented programming. Here what is happening? Here it's saying print an object. Print an object. Object can be of many type. Object can be of many type. Right now we have only learnt about arrays. In the future we'll learn about hash maps. We'll learn about our own objects, our own classes, a student class for example. Then Java will get confused. What do you want me to print? Do you want me to print the student name or class or roll number? Java will get confused. Let's see what it's printing over here. It's printing some random value. How it's generating that random value, let's see. Println taking an object, yeah, it's taking an object. Again we'll know everything you put over here, it's going to call the dot value, and that is going to call dot toString. Dot value dot toString, that's how the sequence works. Okay, dot value is called, yeah, dot value of x. This value is basically saying, okay, if the object is null, just print null. If the object is not null, if it's not pointing to null, toString. Why is it this thing? Because null dot something will give error. This dot something I will dive into detail when we do object-oriented programming. Basically the idea is this object may have access to a few functions or methods, and to get access to those functions and methods you use dot. you use dot for that. So this object may have dot toString. Okay, similarly we did something like you know, system dot out dot println. This dot out may have some method called dot println. But imagine if this object was null, and if you do null dot something, does null contain that object or that particular method or something? If I do something like over here, let's say this was null, object was null, and you did not put this check, and it did something over here like null dot toString. Does null contain anything? Null is null. Does it really contain toString? No, it does not. Null pointer exception. This is a very popular error in Java, and it's an exception in Java, which we will diving deep into when we do object-oriented programming. Okay, for now I was just saying if it's null, we have already covered null. No worries in that. Then it's just going to say okay, print null. Otherwise, get the toString. Object.toString. This is a very important point. So here it's saying that object.toString. Now, what did I mention? Objects can be of many types: array, human class, student class, hash map, or whatever. Java will not know what to print. How does Java know what to print? I have not told Java explicitly that first print number, then roll number, then name, or whatever. In that case, for every object, they have a default representation. It takes a hash code, adds a at to it, and adds some random like characters or whatever. Okay, so you can see whatever it's doing over here. It's a string representation of the object. Okay, it's a textual representation, but this is not very beneficial to us. Okay, that is why in object-oriented programming, if you want to pretty print something, okay, this is something we can only right now you cannot understand this because you have not done object-oriented programming. We will do it very soon, this week only, or like by next week we will do object-oriented programming. Don't worry, everything will make sense then. If you're watching this course after 1 or 2 months, check out the link in the description. We have object-oriented programming already covered. So that is the basic idea, that you can override this method. You can say something like, okay, I don't want Java to use this toString method. I want it to use my own toString method. That is why you do something like this: arrays.toString. Now you are saying, don't use this toString method. Use the toString method available in arrays. Let's see what this is doing. This is printing it in a very nice way. If A is null, print null. If the array is empty, print this. Otherwise, just run a for loop. Add a nice comma, nice bracket and everything. What is the string builder? We will cover later on. Okay. And then in the end, it's just returning it over here. You know. Now if I print this, it will print according to this. Bracket, comma, space, bracket, comma, space, this thing. This is known as function overriding. Function has been overridden. Okay, now it's not using the function, the default one. Similarly, you can create your own toString methods like we will be doing. So in short, that is how it works internally. It's calling the value of function method, that is calling toString, and then it's returning the string. This is actually a string that is printing on the console. Let's take null into example. If it is equal to null, let's say, okay, in the end it's just going to print null. Because of this, let's say you can override this method. You can say something like, okay, I don't want Java to use this toString method. I want it to use my own toString method. That is why you do something like this: arrays.toString. Now you are saying, don't use this toString method. Use the toString method available in arrays. Let's see what this is doing. This is printing it in a very nice way. If A is null, print null. If the array is empty, print this. Otherwise, just run a for loop, add a nice comma, nice bracket and everything. What is the string builder? We will cover later on. Okay. And then in the end, it's just returning it over here, you know. Now if I print this, it will print according to this. Bracket, comma, space, bracket, comma, space, this thing. This is known as function overriding. Function has been overridden. Okay, now it's not using the function, the default one. Similarly, you can create your own toString methods like we will be doing. So in short, that is how it works internally. It's calling the value of function method that is calling toString, and then it's returning the string. This is actually a string that is printing on the console. Let's take null into example. If it is equal to null, let's say, okay, in the end it's just going to print null because of this. If object is equal to null, print null. That's it. That is null. In the end it's just going to print null because of this. If object is equal to null, print null. That's it. That is it. Printing. Make sense? All right. Cool. There's some basic stuff that I want to share. Now let's also look into some operators and stuff because that is also very important. Oh, before that, like one more simple stuff that I can say is that this actually right now over here it's not showing toString, right? But if you convert this into a wrapper class, okay? If I say something like integer num is equal to something like this, and then I can say something like num dot toString, the same thing. Okay, same thing. So internally, it's like using like some wrapper class and adds the toString method on that or whatever. Wrapper classes will learn later on. Something like say class. Okay, if I say something like integer num is equal to something like this, and then I can say something like num dot toString, the same thing. Okay, same thing. So internally, it's like using like some wrapper class and adds the toString method on that or whatever. Wrapper classes will learn later on. Basically, what I'm trying to say is this and this is like the same thing, and that's why it's showing blur over here as well. Like, okay, you don't have to do this; it will do it automatically for you. This will be type object. That's true because integer is wrapper class. In the end, it's only calling value of, which is calling toString. Okay, nothing major over here. So wrapper class basically means that if you want to use all the object-oriented programming principles with integer values, because we know integers are stored in stack memory, okay, and objects are stored in heap memory. So primitives are stored in stack memory. We covered this before previously as well. In Java, because in Python, if you're talking about Python, nothing is primitive. Everything is an object. Everything is in heap. Okay, so that makes an object. This it will do it automatically for you. This will be type object. That's true because integer is wrapper class. In the end, it's only calling value of, which is calling toString. Okay, nothing major over here. So wrapper class basically means that if you want to use all the object-oriented programming principles with integer values, because we know integers are stored in stack memory, okay, and objects are stored in heap memory. So primitives are stored in stack memory. We covered this before previously as well. In Java, because in Python, if you're talking about Python, nothing is primitive. Everything is an object. Everything is in heap. Okay, so that makes sense, right? This is something we'll cover later on. Basically, if you put it in a wrapper class, you can then use so many functions. Okay, so many. You can't do it with integer because integer is not an object. It's a primitive. It does not have classes and stuff. Okay, let's move forward. And I see that it's marked for removal as well. So if you're using future Java versions, I think it will be removed. Yeah, so keep that in mind. All right, let's see. I'm gonna comment this out. And now we are gonna do something called, why am I getting an error over here? Maybe some IntelliJ issue, because this is working fine. Yeah. So I'm getting a red error line over here, but there is literally no error here. So maybe some IntelliJ issue, no problem. Let me run this if this is working. Yeah, working fine. So let's move forward with pretty printing, because in competitive coding you have to do it. Now don't say something like, hey Kunal, this is not the correct way to, you know, some people may get triggered like, hey, this is not how you take input for competitive programming in Java. I know that. I know how to take input for competitive for CP questions in Java. There's like buffer reader and classes and stuff that we'll do in when we do object programming in the syllabus. There's a separate section, fast input output. Okay, we will do that. Right now, let's just focus on how you can print it uh, in an easy way. So for example, if you have something like, let's say you want to print pi or something, like you want to print like till two digit decimal numbers. Okay, so you have something like float a is equal to something like 453 point something like this. Okay, this is float you have. Let's take a little bit smaller number like this. Okay, and then you want to print till two decimal values. So I'm going to say print something like this. I'm going to say formatted number is, then add a placeholder over here. Percentage means a placeholder, and till what decimal values, till how many decimal values do you want it to be? Let's say 2.2f because it's float. Okay, and then just write the name over here, which is a. So first placeholder, uh, first name will be added over here. Okay, this is not going to be print ln, this is going to be print f, formatted string. Let's try to run this. It should show me 453.12. That is correct. If I have it something like this, this, run. So you can see it's also rounding off. It is also rounding off. Okay, so it rounds off as well, printf. Okay, cool. So if you want to print the value of pi, so what is the value of pi? I can say print math.py. Math is a class, it has a variable like a constant variable pi. I did not add a new line, so I'm just going to hide it. There you can see 3.14159 whatever. Let's say I don't want this entire thing, I just want it to be percentage dot, let's say till 3 only. Okay, print f, run this till 3. Very simple stuff. See, it also rounded it off. Okay, this is like pretty printing. You can use it in like other things as well. You can say print f, hello, my name is percentage, I'm adding, let's say, a string, and I am percentage s. So I will say first percentage will be Kunal and second percentage will be cool. I again did not put another new line. No worries. So it says, hello, my name is Kunal and I am cool. So you can see the order in which you have placed the placeholders. In that order only you have to place the variables. So this Kunal will be replaced with the first one. This cool will be replaced with the second one. Okay, you can Google about this. There may be many placeholders. Okay, um, placeholders in Java string something. So percentage s we already did. There might be a list of this. How to format a string, you know, this might be so many ones. So percentage d is over here as well. Okay, and so many ones are, see, yeah, this is the entire thing. Let me write it down. Let me write it down over here. File, I'm just going to say placeholders list.txt, so you can use it. Okay, this is something we use. Similarly, for octal value you can use, for integer you can use I, you know, base 10 integers, hexadecimals and exponential, decimal, character, float we already used, new line, date time. Okay, this is very simple stuff, you can do it. All right, so that was about placeholders. Let's look into some operators, like what type of operators and stuff we can use in you know, operators like plus, minus, multiplication, division, whatever. Operators. Static void main. So if I do something like this, if I say print character A plus character B, what is it going to show? 195. What is it doing? The operator is converting this into its character value, the integer value, this also in its integer value. I think the Unicode or like the ASCII value, I think, yeah, that's correct. And it's just adding that. Pretty straightforward stuff. These are characters. Let's say if I do it in a string way, okay, if I say string A plus string B, now what is happening? Now what is it going to print? Now it concatenated the strings. It said A and B, AB, A plus B is equal to AB. What if I do something like print character A plus 3 is going to say A, B, C, D. Which is 100. If I convert this 100 into a character, we have already done this casting, right? We did it before. D. Okay. So what do we note over here? When you're doing the addition or whatever with characters, it converts it into its ASCII value or whatever in numbers, then it uses that to solve it. With strings, it's not doing that. With strings, it's actually taking string values. Okay, so now you may be asking, hey Kunal, what if you try to add a string with a number? In that case, what will happen? Pause this video and think about it. Right now you know string will not be converted into ASCII value. Then what will happen? Only viable solution, what is it? A1, A1. What is happening over here? Note, important point, mark it down, underline it twice. When an integer is concatenated, means added with a string, it is converted to its wrapper class integer like this. Integer will be converted to integer that will call, you all know what it calls, toString. String, it's fine. So this basically is an integer type. It's going to get converted to this bigger integer. This will call toString. It will give a value of 1. So in the end, this is same as after a few steps, a plus 1. Okay, let's try something else. Let's try to add more complex data types. Let's try to do that. Let's say I do something like print Kunal. Is a string. Let's say we take another object over here. Let's say we can take ArrayList. ArrayList we have already done. What is it going to print? Can anyone share? I mean, pause this video, think about it. Let's run this. It's saying initially ArrayList is empty, then it's converted into Kunal. So we know this will be like an object of type integer, hence it's calling the toString. Void main. So if I do something like this, if I say print character A plus character B, what is it going to show? 195. What is it doing? The operator is converting this into its character value, the integer value, this also in its integer value. I think the Unicode or like the ASCII value, I think, yeah, that's correct. And it's just adding that. Pretty straightforward stuff. These are characters. Let's say if I do it in a string way, okay, if I say string A plus string B, now what is happening? Now what is it going to print? Now it concatenated the strings. It said A and B, AB, A plus B is equal to AB. What if I do something like print character A plus 3 is going to say A, B, C, D. Which is 100. If I convert this 100 into a character, we have already done this casting, right? We did this before. D. Okay. So what do we note over here? When you're doing the addition or whatever with characters, it converts it into its ASCII value or whatever in numbers, then it uses that to solve it. With strings, it's not doing that. With strings, it's actually taking string values. Okay, so now you may be asking, hey Kunal, what if you try to add a string with a number? In that case, what will happen? Pause this video and think about it. Right now, you know, string will not be converted into ASCII value. Then what will happen? Only viable solution, what is it? A1, A1. What is happening over here? Note, important point, mark it down, underline it twice. When an integer is concatenated, means added with a string, it is converted to its wrapper class integer like this. Integer will be converted to integer that will call, you all know what it calls, toString. String, it's fine. So this basically is an integer type. It's going to get converted to this bigger integer. This will call toString. It will give a value of 1. So in the end, this is same as after a few steps, a plus 1. Okay, let's try something else. Let's try to add more complex data types. Let's try to do that. Let's say I do something like print Kunal is a string. Let's say we take another object over here. Let's say we can take ArrayList. ArrayList we have already done. What is it going to print? Can anyone share? I mean, pause this video, think about it. Let's run this. It's saying initially ArrayList is empty, then it's converted into Kunal. So we know this will be like an object of type integer, hence it's calling the toString. What is the toString of ArrayList doing? Returning a normal, brackets stuff. That's it. Returning a normal, since it's empty, it will just return an empty array. Very simple stuff. Cool. You can do something like this as well. You can do something like print Kunal plus new integer 56. It's deprecated right now, but it will still work because it's not when removed right now. This will also work. Again, it will call toString for this because it's an object. You should not be having any doubts. Simple one line answer to all your doubts is what? If there's an object, it will be called toString on this. It will get the string to all your, that's it. You know, returning a normal, since it's empty, it will just return an empty array. Very simple stuff. Cool. You can do something like this as well. You can do something like print Kunal plus new integer 56. It's deprecated right now, but it will still work because it's not when removed right now. This will also work. Again, it will call toString for this because it's an object. You should not be having any doubts. Simple one-line answer to all your doubts is what? If there's an object, it will be called toString on this. It will get the string value added to the string. Similarly, what this is happening. Java will be like, oh, this is not string. Convert it into string. How does it convert anything into string? We looked into it into detail how println works. So it will call the toString method. Method same as like a function. Okay, we already covered functions before. Cool. So that makes sense. All right. Now let's try something else. Let's say print this thing plus this thing. Now what will happen? Error. It's giving me error. It's saying the operator plus cannot be applied to integer and array list. So what is happening over here? The operator plus in Java, it's only defined for primitives and when any one of these values is a string. Does that make sense? This is an expression. This entire thing is an expression. It's a very important point. Please listen carefully. This entire thing is an expression. A plus B plus C plus D minus E divided by F or whatever. Okay. This is an expression. Plus in Java, you can only use with primitives. Okay. You can only use this with primitives. And you can only use this with all the complex objects as well. But the only condition is at least one of these objects should be of type string. So for example, if in anywhere in between I add something like a string, let's say an empty string or something, this will work. Complex object, that's fine. This is also an object of type string. At least one of all the three objects is a string, then it will work. And the entire result will be of what type? String type. Exactly like a string. Define function. Okay, we already covered functions before. Cool. So that makes sense. All right. Now let's try something else. Let's say print this thing plus this thing. Now what will happen? Error. It's giving me error. It's saying the operator plus cannot be applied to integer and array list. So what is happening over here? The operator plus in Java, it's only defined for primitives and when any one of these values is a string. Does that make sense? This is an expression. This entire thing is an expression. It's a very important point. Please listen carefully. This entire thing is an expression. A plus B plus C plus D minus E divided by F or whatever. Okay. This is an expression. Plus in Java, you can only use with primitives. Okay. You can only use this with primitives. And you can only use this with all the complex objects as well. But the only condition is at least one of these objects should be of type string. So for example, if in anywhere in between I add something like a string, let's say an empty string or something, this will work. Complex object, that's fine. This is also an object of type string. At least one of the all the three objects is a string, then it will work. And the entire result will be of what type? String type. String answer is equal to this. Print answer, it will work very fine. 56 an empty string and empty array. 56 an empty string and an empty array. I think that should make it clear. Remember when I clapped, that was an important point. So please mark that down, and it's very important. Okay, so plus operator only works for primitives. People ask questions like, Kunal, what if you add minus over here? What will happen then? Run it. Run it and you will find out. So it's giving me error. Operator minus cannot be applied to string. It's only working for like primitives and stuff. In uh, so yeah, basically the plus operator where we talk about performs like the addition on primitives, and uh, it is basically overloaded for string type. Okay, we know plus from from nursery school, from nursery class we know what plus does. Okay, but this additional functionality that it's concatenating the strings, adding two strings, Java has provided. this separately for us. Java is like, okay, we all know what the use of plus is. We have been studying it from, when we were children. But I will give you some additional functionality on this. This is known as operator overloading. Operator is giving us more functionalities. Okay, so on string objects, the plus operator is being overloaded. So plus basically how is it overloaded? It concatenates more than one strings. Okay, in Java, operator overloading is not supported for some software engineering consideration. Okay, so in C++, operator overloading is supported. So plus operator, you can basically modify what the plus operator is doing in C++. You can do that. You can also do it in Python. You can also make it act like as a multiplication or subtraction or whatever. You can add complex data types or whatever. Anything you can do with plus operator. Okay, but this results in poor code. That is why here in Java it is not supported. Java has only given us operator overloading on its own, like, okay, only I'm making one exception for you in case of strings, but you can't do it on your own. If you want to merge two complex objects of your own type, like a string, like an array or a hash map together, like we were trying to do, it will not allow. You cannot even modify it and do it on your own. You can do it in C++ and Python, but you can do here. Okay, it's the only operator that is intentionally overloaded in Java to support string concatenation or string joining. Okay, so it will not work on any random objects like we already discussed. At least one has to be string. Okay, this is very simple stuff. All right, and you all know this and this is actually creating another string object. I think this is very clear now. Okay, let's try to see how this is working. So it's saying print A and B, right? I'm printing A and B. So I say, don't worry about println and everything working internally and all the methods, how they are being called. You using dot. I will cover that in object-oriented programming. Okay. For that, you need to understand classes and reference variables and objects and then new keyword in detail. It will come very soon. We will do it in 1 week or 2 weeks only. Okay. So basically what we're doing over here is I'm saying print A plus B. So here what is happening is it's actually creating a new object. A plus B gives me a new object AB. It's printing this. Then this function is over. The use of this thing is over. Garbage collector will come and take it. Okay, because this AB is not being stored anywhere. If you try to store it, it will get stored. You can do that as well. Okay, so very simple stuff. So primitives we discussed already, stored in the call stack, and it requires less space, and it's cheaper to manipulate and everything we covered in the data type section or whatever. On the other hand, objects, they are stored in heap. Strings that are not explicitly created new are stored inside the heap in a pool memory, which is known as string pool. The reason for that also we discussed because it's a bit faster. We also discussed about equal to comparison and dot equals comparison, and heap requires more complex memory management and more storage spaces, like we discussed about heaps and everything, like the string pool and everything. Okay, let's talk about the performance of strings. Okay, let's talk about how these things are, like memory performance and stuff. Okay, let me talk about that a little bit. So this red line I'm basically getting for this deprecation, like, hey, this is going to be removed. Please don't use it anymore. I'm going to talk about, what was I talking about? Performance. Very important point for coding rounds. Not just for competitive coding in Java, but actually your interview rounds. This is a very important point for strings. Let's say you say string something like series is equal to initially empty string. Okay, then you say for I is equal to 0, I is less than 26 characters, I plus plus. Character is equal to A plus I. I'm going to convert it into a character because this is an integer. We just saw it. We just saw how we can convert it into, sorry, char ch is equal to this. If I try to print ch, it will print a plus 0 a plus 1 b, a plus 2 c, a plus 3 D. So this will be an integer value of ASCII or Unicode that will be converted into character. This we have done in detail in data types. So if you're not able to understand this, link is in the description. Okay, by the way, make sure you like, share and comment, please. Very important. Pause the video right now, like, share, comment. Run this, it will print all the characters from A to Z. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, Z. Okay, cool. Let's say I want to add it in this series string. I can just do simply like series is equal to series plus ch. I can do that. No problem in this. Here I can say series plus equal to ch. That is also same thing. In the end, if I try to print series, it will just add all the characters. Same thing. Like strings. Let's say you say string something like series is equal to initially empty string. Okay, then you say for I is equal to 0, I is less than 26 characters, I plus plus. Character is equal to A plus I. I'm going to convert it into a character because this is an integer. We just saw it. We just saw how we can convert it into, sorry, char ch is equal to this. If I try to print ch, it will print A plus 0 A plus 1 B, A plus 2 C, A plus 3 D. So this will be an integer value of ASCII or Unicode that will be converted into character. This we have done in detail in data types. So if you're not able to understand this, link is in the description. Okay, by the way, make sure you like, share and comment, please. Very important. Pause the video right now, like, share, comment. Run this, it will print all the characters from A to Z. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, Z. Okay, cool. Let's say I want to add it in this series string. I can just do simply like series is equal to series plus ch. I can do that. No problem in this. Here I can say series plus equal to ch. That is also same thing. In the end, if I try to print series, it will just add all the characters together. We already covered this. This will, add all the characters like this. If this is a character, it will add all the characters together. Let's see how this is working. Because this is a string and a character is being added, so all the characters added. So if you add a character in a string, that character will be added in the string. So for example, if I do something like add a character in a string, that character will be added in the string. So for example, if I do something like this, print a string and a character added. It will become AA or AB, because this string in no way will be converted into any other data type. If one of the data type is string, answer will be string AB. Okay, similar thing is having over here. Initially it was empty, then it will become empty plus A is equal to A. Then it will become what? Series will be A, then it will become A plus B is equal to AB. Then it will be what? AB plus C. Then it will be what? ABC plus D. That is what is happening. Let's try to debug it. So here it's saying initially series is empty. Add A to it, series now becomes A. Add B to it, series now becomes AB. Add C to it, add D to it, E to it F G H I J K L M N O P Q. You can see it over here getting added. You know, R S T U V W X Y Z, and then over print. That's it. Let's see how this is working internally and what the problem over here is. Okay, let's see what the problem is. Okay, so what is the problem over here? Why is it not a very good solution? So when you had your something like initially it was let's say, you know, we had something like series which is equal to an empty string. After loop 1, this will be equal to what? This will be equal to A. Okay, so basically you are saying after first iteration it will be empty plus A. This will give me equal to what? A. After second iteration it will be equal to what? This will be equal to series. Now this is series is equal to A. After that series is equal to what? Old series plus B. This will be equal to AB. After third iteration this will be equal to AB string plus character C. This is equal to ABC. Do you see what is happening over here? New object is being created every time. So if we keep adding to the string, new object is being created every time. It is not changing the original object because we know that strings are immutable. So it's actually creating new string object and copying the old one and then appending the new changes. So if I do, do it again. It will be like, okay, ABC string. It's copying this entire string, then adding D into it and making it a new one, ABCD. Copying it again, ABCD. Adding a new string E over here, ABCDE. So much memory wastage. All these objects are dereferenced because series was first pointing to this, then it will point to this. This will be not be having anything. This after this series will be pointing to this. This will not be having anything pointed to it. After that series will be pointing to this. This will not have anything pointing to it. After that series will be pointing to this. This will not have anything pointing to it. So in the end, what will happen is A, AB, ABC, ABCD, ABCDE, ABCD, EF, ABCD, EFG till ABCDEFGHIJKLMNOPQRSTY. All of these large strings will have no reference variable. Wastage of space. What is the size of this? Size 1, size 2, size 3, size 4, size 5, size 6, size 7, till 26, till character, till n iterations. By now you might be knowing this is a time complexity of big O of n squared. Why? Because size 1 plus string of size 2, strings of size 3, size 4, size 5 till size n. This is equal to what? N into n plus 1 divided by 2 number of comparisons or whatever. This is equal to what? N square plus n divided by 2, big O of n square plus n divided by 2. I have discussed it already that we eliminate constants and less dominating terms. That is why big O of n squared is remaining. Now you may be asking, Kunal, what is big O notation? Why are you eliminating this? Very soon we will cover it in time complexity. For now, just understand that this is how we are getting n squared. Total number of lengths and comparisons we are adding. And why we are actually doing it? Why are we eliminating constants? Why are we eliminating? Dominating term. What is big O notation? We will cover it in time complexity lecture. If you're watching this video in the future, we have already covered it. Check out the link in the description for the time complexity lecture. Okay, so this is n squared. Very bad. So if you want to add n characters in a string, you are having a complexity of n squared. Very bad. Not good. What will be the solution? You tell me what might be the solution? Well, the only viable solution that I can see from here is that wouldn't it be great if there was a sort of data type that will allow us to modify its value? String does not allow us to modify the value. Once an object is created in string, you cannot modify it. You can only create new ones. Wouldn't it be great if there was a data type that will allow us to modify the value? That will allow us to do something like this. Let's say the series was something like this, is equal to something like, let's say A, B, C or whatever. When you add D into it, it will actually make changes in this object only. It will say A, B, C, D. No new object created. So simple terms, it's a very simple solution we have over here. Can we create a sort of data type that is actually not creating new objects but actually adding in just the original object? In that case, if I want to add n items, I can run as just in n iterations. In n times, I can just do it. Even though in our example, we were running the for loop n times. But when I was adding strings together, that itself was also running it once, twice, thrice, 4 times, 5 times, 6 times, 7 times. That's why n squared. This time it will not do it. This time it will just we just add it in the end, like arrays. Like arrays, if you want to add something in an array, just to add into the array. If you want to add n items in the array, it's going to take n operations. That is what we want to do over here. Does exist a data type like this? Yes. It is known as string builder. So string builder only, the only one object is made and the changes are done in that object only. The reference is also the same and it is not changed. Okay, so string builder is a separate data type. We will see it's a separate class, just like string, it's a separate class. Okay, cool. Let's see how that is working internally. All right, so now let's look at string builder. String builder. I did not write this as string builder because string builder is already a class over here. So I cannot name this one as string builder also. So I can say string builder. I can name it anything. Builder is equal to new string builder. Now I can keep on adding on this. I can say builder dot add, or I can just take the previous example only. Okay, I can say builder dot add. Ch. In the end, I can just say print builder. After you are done with all the calculations and everything, you can also convert it into a string. So I can say builder.toString, which is not required because it calls is internally only. So ta-da! But now what is the difference? Difference between this and this? It is not actually creating new objects. It's only changing in this original object that was created. It is actually changing this. So this is not immutable. This is mutable. Just like arrays we can change, this is also something we can change. Okay, cool. So you can check out all the and say methods that are available. Builder.append. You can append a character, integer, or whatever. Builder.toString. Compared to, you can which is not required because it calls is internally only. So ta-da! But now what is the difference? Difference between this and this? It is not actually creating new objects. It's only changing in this original object that was created. it is actually changing this. So this is not immutable, this is mutable. Just like arrays we can change, this is also something we can change. Okay, cool. So you can check out all the you can say methods that are available. Builder.append, you can append a character, integer, or whatever. Builder.toString, compared to, you can delete, you can delete a character at a particular index. You can take the index of the, I don't think I should be running all these things. So if I say delete character at 0, then I print it, it's going to delete A. Is there anything different over here? Deleted A. Pretty self-explanatory. I don't think I have to run every single one. So homework for you is try what all these things are doing all on its own. Not many one. Index of, it will give you an index. Insert, insert at a particular index or whatever. Last index, replace. You can also reverse it and whatever. You can reverse it, you can do that. Builder, and reverse it. Reversed. Very simple stuff. Okay, cool. Let's look into some. So this is like very basic stuff, because we'll be doing something similar right now with strings, where we'll be actually looking into like the what are methods and everything that strings provide. It looks like very basic stuff, because we'll be doing something similar right now with strings, where we'll be actually looking into like the what are methods and everything that strings provide. So let's look into that. So I'm going to create a new methods class. Okay, public static void main. So I can say string name is equal to Kunal Kushwaha. Name dot to char array. It's actually going to convert it into a character array. So you can print this. Print name dot char array. I think it's I think you have to do 1 second. Arrays dot toString. ToString. That's it. It will create it into a character array. Very simple stuff. Another thing you can do is name dot get bytes. You can say dot equals, we already covered length. It's going to give you the length. Nothing new over here. ToString is very simple, and to lowercase it will convert this into lowercase. It's not actually going to convert the original object, because we already know immutable. Okay, so for example, if I print this in lowercase, then I print the original one will not change. It's actually creating a new object, lowercase, but the original one did not change. Similarly, you can say name dot what else is interesting, to uppercase. Character at, we already discussed, one of the most important ones. Get a character at a particular index. All these other things. Concat, compare to, content equals, index of. Index of basically means it's going to be the index. So basically I can say index of A is actually going to give me the first index, this one, 0 1 2 3 3. You can also take index of from last. I did not print it. My bad. Over here. Okay, so you can say name dot index, last index of, okay, it's taking from the last index. And then you can say from index, if you want to take from a particular index, where is this element lying. Okay, you can also do other things like replace. You can replace it, you can strip it. Okay, you can transform it, you can trim it. trim it, you can strip it as well. So I can say something like dot strip. You can do something like this. Dot strip, what is it doing? Let's say. So it's basically saying that return a string whose value in this white spaces are removed. These white spaces, the extra spaces at the ends of the string will be removed. I can just print this. So many ones you can also already explore yourself. This will be removed. It's removed. Okay. And also split it. You can say name dot split, and you have to add a regex over here. So if I say something like I need to split it into, let's say, a space. So wherever you have a space, split it over there. It's actually returning a string array. So I can just say arrays.toString were already called, I think. Let me just see. Let me just double check. No, I would have to call it arrays.toString. So what all, so there's just one space over here, right? So over here the array is divided over here. This space basically means take a scissor, cut this array wherever we have spaces. Kunal Kushwaha, hello world. So this will be cut over here, this will cut over here, and cut over here. So this array will have 4 elements, 1, 2, 3, and 4. That is true. It will have 4. 1, 2, 3, and 4. Very simple stuff. Okay. Now, as we move forward in the course, definitely we'll be doing more and more questions on strings like we did arrays previously. Does that really mean that arrays is over now? No. So many other patterns to come. We'll use it in all the other data structures as well. Similarly for strings also. Okay. So in the other futures till the end, we will doing like these basic data structures like arrays and strings. So I'll upload the assignment for this. Let's do one simple question just so that you have some sort of a feeling of doing a basic question, and then I'll upload a second separate video. Because if you've been following our course, what we do is we upload one video on the theory, we upload a second video on only questions. Okay, so that only questions video on strings we will be doing later on in the future. So simple one can we do is that if a string is palindrome or not. Okay, let's say that is a question. So example, you're given something like A, B, C, D, C, B, A. This is a palindrome. Palindrome basically means what? Palindrome means that initial, if you read it from here, it should be same. If you read it from right to left, it should be same. Left to right, it should be same. Like A, B, A. A, B, C, B, A. So A, B, C, B, A, A, B, C, B, A. We have to check, a string is given, we have to check whether it is a palindrome or not. Many ways you can do this. Reverse this string, check whether it was equal to the original string or not. That is one way you can do this. Um, yeah, create a string builder or whatever, then start adding in that string builder in reverse order. Then if the value is same, then that's your palindrome or whatever. Simple thing we can do is that we know that this and this second half, this should be like in reverse, should be equal but in reverse. So what we can do is we can take a start and end pointer. By the way, I don't think I have to explain this because we already covered this in the array lecture. So A, B, C, D, C, B, A. Take a start pointer over here, end pointer over here. Is start equal to end? Yes, it is. Move start ahead by 1, end ahead by end minus 1. Is start equal to end? Yes, it is. Start will move ahead, end will move before. Is start equal to end? Yes, it is. Start will move ahead, end will move before. Is start equal to end? Yes, it is. Start will move ahead, end will move before. While loop will end over here. Loop ends. We can also use a for loop. Since we know we are only going till the half of the array, we can run the for loop till half of the array. We can do that. If it contains, let's say, you know, same number of items, let's sorry, even number of items, A, B, C, C, B, A. Over here also same thing will work. Start is equal to end, yes it is. End will come over here, start. Start equal to end, yes it is. And like this. Start equal to end, yes it is. Loop break. You can either run a while loop or you can either run a for loop till like the half of the array. As simple as that. Just check whether the array, if at any particular point of time the elements are not equal. For example, if you have something like A, B, C, B, D, A. Okay. Is A equal to A? Start and end. Is A equal to A? Yes, it is. End will come over here. Start will come over. Is B equal to D? No, it's not. Return false. No need to check. If you found one violation, it means that the overall answer is false. That's what we're going to do. As simple as that. Let's try to solve it and I'll create more videos on the questions part. Okay, so I'm going to create a new class called palindrome. Cool. So here I'm just going to say that I'm going to create another function. I'm going to say static, it's returning true or false. So Boolean is palindrome and it's just taking a string str. That's it. I'm just going to say that first I'm going to convert this into lowercase. I'm going to say string is equal to string dot to lowercase. Okay. And then I'm just going to say I'm going to go till the half of the length, right? So very simple stuff. For I is equal to 0, less than equal to string dot length divided by 2. And by the way, one more thing. You can see that internally, this is like when I do array.length, in that I don't have to call this thing. So array.length is actually that length is a variable. Here length is a function or a method. Internally also it's doing the same thing. The length variable it's using because internally it's also working as an array. Okay. So don't be confused. Hey Kunal, why are we using dot length in array and dot length as a function or a method when using strings? Because this is a a class that we're using and internally also it's doing the same thing only. Okay, it's doing the same thing. Okay, so I'm going to say that if start is not equal to end, char start is going to be equal to what? Char start is going to be equal to what? Str string dot char at I, and char end is going to be equal to what? String dot char at length minus I, length minus 1, which is the last one. So the last index is going to be length minus 1, string dot length minus 1. This is going to be the last index. So when the value of I is 0, it's going to compare the index at element 0 and last. When the value of I is 1, start will be 1, end should be last minus 1. When the I is value is 2, start will be 2, end should be end index minus 2. So every time you are doing minus I also. Okay, now I just need to check if str dot, oh sorry, start character, yeah. If start is not equal to end, just return false. We know once it returns, the function will be over, it will come out over here wherever it's called. False. We know once it returns, the function will be over, it will come out over here wherever it's called. That's it. Otherwise, what we can do? Otherwise, after the loop has finished running, and no false was returned, it basically means our answer is true. Yeah, it is a palindrome. So if I just try to run this, I can just say string str is equal to something. I'll fill this later on. And then I can just say print is palindrome. Is this string palindrome or not? Let's say I say A, B, C, D, C, B, A. So it's basically going to say true, it's palindrome. If I remove it like this, if it's like even characters, in that case also it will work true. Yeah, if I add something like Y over here, then it will say false. Cool. If I just add a single character, that is also a palindrome, true. Okay, if I add an empty string, let's see for that, should also come true. But we are getting an exception, index out of bound. That's why we have to put a check over here. If str.length is equal to 0, return true. Or I can say if str is equal to null, this should come over here. Yeah, make sense? Over here. Or that makes sense. Because if string.length is equal to 0, that basically means that this check is, you know, because if we put it over here, null is not of size 0, right? That's why I have to put this check over here first. Because if it was null, then if I put this first, it will give me error. Okay. This should give me true now, empty string. Yeah. If I put this as null, that should also give me true. Yeah. If I put this as null, that should also give me true. It's totally up to you. You can put null as false as well or whatever. Ask the interviewer. Here I'm taking null as true. If the interviewer says null as false, put false. That looks pretty good. And time complexity is also O of n only because just one pass. So very simple stuff. O of n by 2 is O of n only because constants are ignored. Why? We will look into time complexity lecture. But yeah, that looks good. And that's pretty much about it. Cool. So I will see you in the next video. If you like this, please make sure you like right now, comment if you loved it, and subscribe. I'm sure you've already subscribed because I see the nice stats on YouTube studio. So that's really grateful to you all. We'll be uploading more and more lectures, very advanced topics, complete, detailed. And make sure you share with your friends. Check out the assignments and the previous videos. All the things are in the link. Then 6, then 7, then 8, then 9. So this 7, 8, 9, for example, will only execute when the answer of 3 is given to us. Hey everyone, welcome back to another video. And in this video, we're talking about maths for data structures and algorithms. Now, this is a two-part video because in this one, we'll be doing like introduction and complete like bitwise operators, prime numbers, and some techniques for that, HCF, LCM number theory stuff, square root method, Euclidean algorithms, and some modulo properties. That's like a lot of content. Maths is much more than that. We have like combinations and like permutations, combinations. We have game theory and all these other things. Um, these are like some of the basic ones like that you study in high school. But I'll be going more over those and some of the other topics like Fermat's theorems and Chinese remainder theorem and some other more advanced level mathematics that they are not going to ask in interviews. But it's good to know, let's say for computer coding or just for your own good knowledge. There are some advanced concepts as well. And if you check the GitHub issue of the DSA, like the link is in the description, there's a separate issue I've created which is known as advanced concepts. So I'll be covering these as well, and everything that I mentioned in the issues will be covered. So let's get started. Yeah, before we get started, for those of you who are new to the channel, I always say it, we have an entire DSA complete bootcamp going on. It's free. The entire playlist is in the description below, so make sure you check it out. Without further ado, let's get started. All right, so let's start with the very first thing, which is bitwise operators. Very important topic, also in terms of interview rounds and CPE or whatever you want to do. It's very, very important. So bitwise operators, right? Bit manipulation. First, you have to understand what it is, and then we'll look at some of the concepts and obviously questions. So when we write something like, a is equal to 10, something like this. In Java, we write, let's say int a is equal to 10 or something, or in any language. Internally, whatever things that you're doing, the video you're watching right now, all the servers that are running, all the applications, IntelliJ IDEA that you use, internally at the very minute thing, it's all a bunch of zeros and ones. Okay, and that's what computer understands. Because so in the first lecture we learned about like you know your programming language that you write that gets converted into, let's say, machine code. That machine code is understandable by the machine, for example. These are like the zeros and ones. Okay, and we already talked about like we can definitely write in zeros and ones as well, but it's like not possible. It was very complex stuff. All right, that's why we have programming languages. So that's how numbers get stored like internally. This is known as number system. So there are various number systems: base 10, base 8, base 16, base 2. We'll learn about what this base represents. So base basically means how many numbers do we have in that particular uh, number theory, like the base concepts. For example, if I'm saying which base concept have we been studying since we were like in kindergarten? Base 10. Why? Because we have been studying only 10 numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Using these 10 numbers, we are able to create all the numbers, right? So that's what we have been studying, base 10 numbers. These are known as decimal number system. So which number system we have been studying since we were kids? Decimal number system. Now you may ask, Kunal, why? Why are we not studying other number systems? Why are we studying decimal number system? Why do all the, you know, finances and all these other things, day-to-day life things, everything's happen on decimal number system, your page numbers of your books or whatever? The reason for that is it's a very very valid reason, because we have 10 fingers, so we're able to count it like on 10 numbers. That's why I think. Not sure, maybe if there's some other reason, let me know in the comments below. But similarly, there are other number systems. Base 2 number system means binary number system. This is what the computer understands. So using just 0 and 1, computer can make anything that you can in normal language like Python or Java or whatever. Okay, and that's what we're going to study about in this lecture. How to convert one number system to another number system is also very important for your exams in BTech or high school or whatever, if you have computer science. So let's first look into it. So I'm going to say bit manipulation. That's the topic for today. Let's learn about some of the concepts, like first some of the operators first. So we already have learned about operators. I mean, we've been learning about operators since we were in kindergarten, like the addition operator, the subtraction operator, multiplication, division, right? You have A, you have B, you have 10 and 20. You say 10 plus 20, it will give you 30. Okay, so these are like mathematical operators. We have some bitwise operators as well. They also have their own use cases. Let's look at the first one. Let's say if I'm talking about operators. Okay, let's look at the first one. And. Okay, this is the first operator, bitwise and. Bitwise and basically means if there are two numbers, okay, then A and B. This is basically going to say that any type of any number of numbers that you have here, let's say I have two numbers. So both the numbers, like all of the numbers, should be true. Okay, we can imagine, let's say 0 means false, 1 means true. So false and false. If A is false and B is false, then A and B should be false as well. Because what is the condition for AND? AND condition means that all the numbers and things that you have between ANDs, everything should be true. Then only the entire expression will be true. Then only this entire thing will be true. Okay, so false and false, obviously false. False and true, one of those is false. hence it's false. True and false, this is also false. True and true, yeah, this is true because everyone is true. Okay, that's basically the idea of and. Alright, everything should be true. If you're saying A and B and C, then both all the A, B and C, all the three should be true. All the three should be equal to 1. So in computer science you can say that 1 means true, or the connection like gate is open or whatever, or selected. If you have done electronics, 0 means false. Okay, switch is closed. Switch is open. 1 means, yeah, closed, like current is flowing. Let's not go into that. It's a very, I did not like that subject. Alright, so now you might be asking, now what's the use case of this? What is the use case of this? Okay, a question can be given to you, something like this. Let's say a question given to you is like, given number n, find if it's even or odd. Okay, you can solve this with a single AND operator without using the comparators like if number percent 2 is equal to 1 then it is odd. No, that's old way. You can use AND operator for that. How? I'll tell you later because right now we have not learned about like binary number representation, so I'll teach you that later. Alright, so that is pretty much about it, and because obviously we'll be doing questions. So one thing I want you to note over here is, as you can see that whenever you AND, when you AND 1 with any number, digits remain the same. Okay, if you AND with 1, the digits will remain the same. Digits remain the same. So for example, I can talk about 1 1 0 0 1 0 1 0 0. I can AND this with, let's say, all with 1. 0 and 1 0, 0 and 1 0, 1 and 1 1, 0 and 1 0 1 0 0 1 1. Isn't this and this same? This is like a nice observation I wanted you to have. But these are just observations. All of these observations will be applying when we do questions in this video itself. Okay, second operator, also very easy one, bitwise OR operator. OR is like opposite of AND. It means that if any one is true, entire expression is true. If any one is true, entire expression is true. For example, I can have A, B, 0 0 1 1, 0 1 0 1, A or B. Both are false, this will be false. This is false, but this is true. Any one is true, that's true. Okay, entire expression is true. Any one is true, yeah, that's true. Any one should be true. Here both are true, yeah, that's also true. Or B, both are false, this will be false. This is false, but this is true. Any one is true, that's true. Okay, entire expression is true. Any one is true, yeah, that's true. Any one should be true. Here both are true, yeah, that's also true. Okay, that's bitwise OR. Don't worry, we'll be like learning about it. We'll be doing so many nice questions right now. So bear with me a little bit. Let me just get the basics away first of all. Basics cleared. Third one, another very important one. This is something we'll be using a lot. XOR. Symbol for this is this. It means if and only if. Okay, if and only if. It's like exclusive OR. It means exclusive OR. Basically means that if you have two numbers, then only one of those should be true. Only one should be true. A, B, A XOR B. If you have something like this, both are false, false. At least one should be true. Sorry, only one should be true. One is true, yeah, that's true. Only one should be true, yes, that's true. Only one should be true. Here, everything is true, false. So, if more than one number, it can be like odd numbers should be true. Okay. So, both are false, false. At least one should be true. Sorry, only one should be true. One is true, yeah, that's true. Only one should be true, yes, that's true. Only one should be true. Here, everything is true, false. So, if more than one number, it can be like odd numbers should be true. Okay. Cool. Some important observations over here. These observations are the things that will help you in solving the questions. Okay. So that's why I'm writing this in red. Nice observation. I can just write it, mark it with red over here. Okay. Observation that you can see is if I AND any number, sorry, not AND, XOR. If I XOR any number with 1, what am I getting? XOR any number with 1, I am getting the complement of that number. Complement means opposite. Okay, you can see if I did 0 XOR 1, I got 1. So 0 got converted to 1. I did 1 XOR 0. Okay, oh, sorry, I did 1 XOR 1. So 1 got converted to 0. Anything XOR with 1, you will get the answer opposite of that. 0's opposite is 1, yeah, that's the answer. 1 opposite is 0, yeah, that's true. 0 is the answer. Complement basically means I'll teach you how to do. So right now we are only learning like doing zeros and ones, but I'll be teaching you like how do we actually go ahead with doing it like the entire for entire like bigger numbers as well and not just zeros and one. Let's say if I say 32 and 47, for example, 35 and 16, 37 XOR 44, something like that. That's also a valid thing. Nothing new. In this case, what you need to do is basically convert all these individual numbers into binary representations and do the normal thing. That's the only thing. Okay, so bear with me. So these are some of the observations and these are like facts, no need for explanation in this. So if you XOR it with 1, it will give you the complement of this. If you XOR it with 0, it will give you the number itself. So you can see whenever I say 0 XOR 0 gives me 0, 1 XOR 0 gives me 1. And if you XOR the same number with the same number, obviously nothing is exclusive now, hence the answer will be 0. Okay, 32 XOR 32, 0. 5 million XOR 5 million, 0. Okay, cool. Okay, and since we were talking about the complement one, so let me just write that down as well over here. So I can say the complement operators, it's like something like this. So it just makes it, opposite. So if A is equal to 1 0 1 1 0, something like that, A complement is going to be equal to 0 1 0 0 1. That's it. All right, very basic stuff. But before we move forward, let's also look into like the main part, like how do you actually represent a number in terms of binary or any other number? Because then only we'll be able to solve all the problems and understand all the concepts. Now let's look into a very important topic, which is conversion of like number systems, right? Conversion into various bases. So if I'm saying I'm writing int a is equal to 10, how is that being stored in like my memory in my computer? So I'm going to teach you like two ways via which you can convert any number into any other number. Okay, so let's first look at what all bases are available. Okay, so let's provide to variable, which is conversion of the number, because then only we'll be able to enter something opposite. So if a is equal to 10110, something like that, a complement is going to be equal to 01001. That's it. All right, very basic stuff. But before we move forward, let's also look into like the main part, like how do you actually represent a number in terms of binary or any other number, because then only we'll be able to solve all the problems and understand all the concepts. Now let's look into a very important topic, which is conversion of like number systems, right? Conversion into various bases. So if I'm saying I'm writing int a is equal to 10, how is that being stored in like my memory in my computer? So I'm going to teach you like two ways via which you can convert any number into any other number. Okay, so let's first look at what all bases are available. Okay, so number systems. So the first one we have is like the decimal number system. Okay, decimal number system. This contains like 0, 1, 2 up to 9. Okay, this is of base 10. Base 10 means there are 10 numbers which you can use to represent any number in decimal form. If I want to represent 357, it will be just 357. I can say base is 10. That's it. If I want to represent 10, 10 is basically like this, base is 10. Second, we can talk about our like binary numbers, for example. Binary numbers, it only uses 0 and 1, hence the base is 2. So example, if you want to represent 10 in binary number, so it's going to be, so 10, which is in decimal number, in binary number it's equal to 1010 base 2. So if you write int a is equal to 10, the computer stores it as 1010. If you're talking about 7 in binary, 7 is a decimal number. In binary, it's written as 111, I think. Okay. But how? Kunal, how do you know this? How are we converting it from decimal to binary, binary to decimal? Okay. So let me find binary my computer. So I'm going to teach you like two ways via which you can convert any number into any other number. Okay, so let's first look at what all bases are available. Okay, so number systems. So the first one we have is like a decimal number system. Okay, decimal number system. This contains like 0, 1, 2 up to 9. Okay, this is of base 10. Base 10 means there are 10 numbers which you can use to represent any number in decimal form. If you want to represent 357, it will be just 357. I can say base is 10. That's it. If you want to represent 10, 10 is basically like this, base is 10. Second, we can talk about our like binary numbers, for example. Binary numbers, it only uses 0 and 1, hence the base is 2. So example, if you want to represent 10 in binary number, so it's going to be, so 10, which is in decimal number, in binary number it's equal to 1010 base 2. So if you write int a is equal to 10, the computer stores it as 1010. If you're talking about 7 in binary, 7 is a decimal number, in binary it's written as 111, I think. Okay, but how? Kunal, how do you know this? How are we converting it from decimal to binary, binary to decimal? Okay, so let me first tell you some other bases that exist. Then I will literally teach you how to convert from one base to another base, any bases. Okay, so let's see more bases that are involved. Okay, now the third one that I can say that exists is octal base. This is numbers from 0, 1, 2, 3 till 7. Hence base is 8. Okay, very cool stuff. So basically it's similar to numbers, right? Like the ones we have done since we were children. Like if I'm talking about decimal number system, let's count decimal numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Similarly with octal, 0, 1, 2, 3, 4, 5, 6, 7, 8 does not exist. Okay, so if I'm talking about counting, so I can say, okay, 0 in decimal, if I'm counting, I can have something like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, so on and so forth. In octal, if I'm counting like this, remember I can only use digits from 0 till 7. Hence, I cannot use 8, 9. Okay, I cannot use numbers that contain 8 or 9. So I can say octal can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 will not be there. I can say 10, 11, 12, 13, 14, 15, 16, 17, 18 cannot be there because it contains 8 and 8 is not in octal. 19 cannot be there, 20 is there. Okay, so what am I saying? Basically means that 8 in decimal is equal to 10 in octal. 9 in decimal is equal to 11 in octal. Okay, 9 in decimal is equal to 11 in base 8. There's a fourth one, hexadecimal. This is being used by a lot of computer programming languages internally. So many hexadecimal, like you represent addresses and stuff sometimes in some complex notations and stuff. So this basically says that you have 16 in total, 0 to 9. So you have 0 to 9 and you have A till F. So you have basically in hexadecimal you have something like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So 10, 11, 12, 13, 14, 15, 16 numbers total. Okay, base 16. So you can say 10 in decimal is equal to F by something like this: 6, 7, 8, 9, A, B, C, D, E, F. So 10, 11, 12, 13, 14, 15, 16 numbers total. Okay, base 16. So you can say 10 in decimal is equal to F, not F, A in binary. Not binary, hexadecimal, A in hexadecimal. Okay, A in hexadecimal. 12 normal one is equal to what? 9, 10, 11, 12. C in hexadecimal. We'll cover all these things. Let's do it right now. Okay, so now a new topic will start. We'll say, how do we convert from one number system to another number system? How do we do that? Okay, so let's talk about conversions. Very important point, because after this we'll be able to do so many questions. We'll be able to understand so many concepts and so many other things. Conversion. There are two things you have to remember. Okay, using these 2 points, you will be able to convert from any number system to any number system. Just these 2 points. Point number 1, conversion from decimal to base B, and the second one is conversion from base B to decimal. That is it. The simple answer for this is keep dividing, or let me just remove this thing and write it separately. Decimal to any base B. So for example, the question can be convert 17. Okay, can be convert normal 17 in decimal to, let's say, base 2. So the key is that keep dividing by base. Take remainders and write in opposite. For example, 17 base 10 to base 2. So 17, it's saying, okay, keep dividing 17 by whatever base is given. Okay, base 2 is given. 17, I'm going to divide by 2. It's going to be like 2 into 8 is 16. Remainder is 1. and now this is going to be like 2 fours are 8, remainder is 0. It's going to be 2 twos are 4, remainder is 0. 2 ones are 2, remainder is 0. These are all the remainders. 8 is 16, I'm going to divide by 2. It's going to be like 2 into 8 is 16, remainder is 1. And now this is going to be like 2 fours are 8, remainder is 0. It's going to be 2 twos are 4, remainder is 0. 2 ones are 2, remainder is 0. These are all the remainders. I'm going to write it in opposite. So I'm going to say 1 0 0 1 0 0 0 1, not 0 0 0 1. Remainder is 0. 2 ones are 2, remainder is 0. These are all the remainders. I'm going to write it in opposite. So I'm going to say 1 0 0 1 0 0 0 1. Not 10, it's base 2. Okay, so 17 actually, 17 in binary number. So when you write int a is equal to 17, computer will store it like this. Each RAM and everything has their individual cells. So in RAM, it will be stored like, something like this. These are like cells of RAMs or whatever. It will be 1 0 0 0 1. And A will be pointing to something like this. That's how it works internally, right? Cool. That's how numbers and everything. Internally, everything is like zeros and ones only. Okay. So that is how you can convert any base to any other base. If you want to check, hey, can I convert the base 17, sorry, base 10 into, let's say, in base 8? In octal, what is it going to be? Keep dividing by 8. 8 2 ja 16, remainder is 1. That's it. And yeah, that's it. 21. 17 in base 10 is equal to 21 in base 8. Okay, very simple stuff. Now the second point is how can you convert any base to decimal? That's second point. Convert any base to decimal. Convert any base b to decimal. So let's say we can take the previous question only. Convert in binary, let's say in base 2 you're given this. What is this in base 10? So the steps for this is multiply and add the power of base with digits. First thing you have to do is write the power of the base. Base is 2, so you can start from 0. So you can see 2 raised to power 0 multiplied by the first number from the right hand side, which is 1, plus 2 raised to power 1 into the second number 0, plus 2 raised to power 3 into the third number 0, plus 2 raised to power 4 into the
यहाँ पर हम शुरुआत में स्मॉलेस्ट एलिमेंट भर रहे हैं, तो यहाँ पर भी जिस एरे को हमें सॉर्ट करना है उसकी लेंथ कम हो रही है, पर वो सामने से कम हो रही है, पहले पीछे से कम हो रही थी। अब यहाँ पर क्या करेंगे, यहाँ पर हम स्मॉलेस्ट एलिमेंट को चेक करेंगे कि अगर हमारा एरे ऑफ स्मॉलेस्ट किसी अगले एलिमेंट से ग्रेटर हो जाता है, यानी एरे ऑफ जे से ग्रेटर हो जाता है, तो उस केस में हम उस जे को स्मॉलेस्ट बना देंगे। एंड में क्या करेंगे, स्वैप कर देंगे आई को अपने स्मॉलेस्ट के साथ, यानी शुरुआत वाला जो एलिमेंट था वहां पर लाकर प्लेस कर देंगे अपने स्मॉलेस्ट एलिमेंट को। तो स्वैप करने के लिए टेम्परेरी हमने वेरिएबल बना लिया जिसमें स्टोर कर लिया एरे ऑफ स्मॉलेस्ट को। अब एरे